Okay, I'm going to go over a few of the problems from this last assignment, the second of the two assignments that are on the test. The key information you need to know is right up here on the top. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. That's your SOHCAHTOA. And then their reciprocals. Remember that, how you remember the reciprocal of cosecant, look at the middle letter. You see the S there, and just remember that then go along with sine. Cotangent sounds just like tangent, so obviously those go together, and obviously by process of elimination, secant is the reciprocal of cosine. So reciprocal means switch the numerator and denominator, as you see in all these cases. Also, don't forget, anytime you have a 30-60-90 degree triangle, anytime your angle measure is a multiple of the 30 degrees or 60 degrees and it falls within a quadrant, not on the x or y axis, you will use these numbers for your side lengths. Hypotenuse is always 1. Anytime the triangle falls within one of the four quadrants, so 45, 135, 225, and 315, you will use these side lengths right here. Okay, hypotenuse always 1. Because again, it's a unit circle, unit meaning 1. So that is why these numbers cannot change ever in these triangles. Again, that is only for the unit circle. Now, because the hypotenuse is 1, opposite divided by 1 is still the opposite. So that means the sine is the y coordinate. Adjacent divided by 1, it means it's only the adjacent. And the adjacent is always the x coordinate. If you look at our theta right here, our reference angle, the adjacent is here, the adjacent is here, the adjacent is here. It's always on the x-axis. The opposite is all opposite of the 60-degree reference angle here. Opposite, that's the y coordinate. Opposite y coordinate, opposite y coordinate. And that's why you can say the sine is the y coordinate. And then lastly, you have tangent. Remember, tangent is opposite over adjacent. Well, we just got done saying the opposite is the y coordinate. The adjacent is the x coordinate, so therefore tangent is y over x. And then of course the reciprocals. A reciprocal means 1 over that, so 1 over y, 1 over x, and the reciprocal of y over x is x over y. So you can use these ones within the unit circle. If it's not a unit circle, if the hypotenuse is not 1, you must go back and use these right here. You can use these all the time, so if you don't want to have to remember these right here, even though these will save you some time, you can always use this every single time. Okay, all right, so I'm going to just pick 1 or 2 from each row right here. So let's say number 2, cotangent of 60 degrees. So remember, 60 degrees is obviously between 0 and 90, quadrant 1. To find the reference angle, remember we take the angle measure minus 0 if it's in quadrant 1. So 60 minus 0 is 60, and that makes the other side 30. Obviously the hypotenuse is 1. Opposite, the 30-degree side is half the hypotenuse, 1/2. And then the 60-degree side is always root 3 over 2. Again, we have that right up here. Okay, we put our signs up here in quadrant 1. Here's a point in quadrant 1. The signs will be positive and positive. Positive in the x, positive for the y. So we checked, are both of our signs positive? Yes. So we're good to go for our triangle. And now we answer the trig question, cotangent. Cotangent, as we see, is adjacent over opposite, or you can think of it as x over y. So the x, 1/2, divided by y. Remember, we changed division to multiplication by the reciprocals. So I've just done that already right away. Division is multiplication by the reciprocal. Cross cancel the 2's, multiply share across, and I get 1 over root 3. Remember, I cannot have a radical in the denominator, so I must rationalize it. Multiply by root 3 over root 3, and now multiply across, and I get root 3 over 3. Let's go down to the next one here. I'm trying to pick some that takes some more work, such as these right here. So let's go ahead and go secant of 150. So here's 150 degrees, again, between 90 and 180. Our reference angle, we take this 180, the one on the x-axis, never any of the 90 or 270 on the y-axis. Don't forget that. Just the x-axis. So 180 minus my angle measure, 150, gives me 30 degrees. There's my reference angle, so therefore the other one is 60. Again, every time I have a 30, 60, 90, my hypotenuse is 1, the 30-degree side is 1/2, and the 60-degree side is root 3 over 2. Now I go ahead and if I plot any point in quadrant 2, I'm going negative on the x, positive on the y. That's why you see negative and positive. So my x coordinate better be negative. There I put on the negative sign. Y coordinate is positive. Yes, it is. So my unit circle triangle here is complete. Now I go ahead and do the trig function itself, secant. Secant is the reciprocal of cosine. Remember, cosine is the x-coordinate, so 1 over the x-coordinate. 1 divided by negative root 3 over 2. Or 1 divided by anything is really just the reciprocal. So the reciprocal of negative root 3 over 2 is 2 over, or negative 2 over root 3. Again, I cannot have a radical in the denominator, so I must rationalize it, multiply by root 3 over root 3. Notice that never changes. It's always by root 3 over root 3. And don't forget, root 3 over root 3 equals 1, so I'm not changing the problem at all. I'm really just multiplying by 1. So now I just multiply straight across, and I get negative 2 root 3 over 3. Okay, let's come on down here. Let's go ahead and look at secant of 225. 225 is between 180 and 270 right here. And how do I get that reference angle? The angle measure minus this 180 right here on the x-axis. So 225 minus 180 is 45. So we have a 45, 45, 90. Remember on any 45, 45, 90 degree triangles, the side lengths are root 2 over root 2, root 2 over root 2, and 1. Now what I need to check is, I don't know why this negative sign didn't come down with it. It's got stuck up there. It's supposed to be right down here. Okay. So we have in any point in quadrant 3, we know I'm going negative on the x and negative on the y. So we see negative, negative, so I make sure my negatives are on the x and the y. Remember, the hypotenuse is always positive, and if it's in the unit circle, it's always 1. So we have our triangle complete. Now we go ahead and do the trig function secant. Secant is, again, the 1 over cosine. Cosine is the x-coordinate. So 1 divided by negative root 2 over 2. Remember, 1 divided by something just means a reciprocal. So flip this upside down, and I get negative 2 over root 2. Again, no radicals in the denominator, so rationalize it. Multiply root 2 over root 2. Change this irrational number of root 2 into a rational number of 2 when I multiply across. I get negative 2 root 2 over 2, and then the 2's cancel, and so I'll left with just negative root 2 up here. Okay, let's go ahead and look at one from this row. If you notice, we don't have any triangles drawn from this row. That's because all these angle measures land either on the x or the y axis. 270 right down here at 0, negative 1, 0 right here, 90 up here, and 180 over here. So remember, it's a unit circle, so the radius is 1. That's why these distances are always 1 unit away from the origin. Okay. Let's take one that ends up being undefined, because a lot of students end up messing up on undefined problems. Okay, so cotangent of 0 degrees. Well, at 0 degrees, the point is 1, 0. Cotangent is x over y. So the x coordinate is 1, the y coordinate is 0. You can never divide by 0. So the answer is always undefined. You can shorten it to UND for undefined. If you want to write out the whole word undefined, that's fine as well. Okay, so anytime you have 0 in the denominator, you need to remember it is undefined. 0 divided by 1 is 0. Or 0 divided by negative 1 is also 0. Okay, all right, let's go to the other side and we'll do a few of these problems. Okay, so we'll pick one right here, for example. If theta is an acute angle on a right triangle, acute means between 0 and 90 degrees. So that's quadrant 1. Theta, remember, is always between this terminal side and the x-axis. Also, if you want to think of it as a triangle, it's between the hypotenuse and the x-axis. Okay. Now, the difference between this side and the other side in the prior worksheet is that the hypotenuse no longer is 1. So we're no longer working with the unit circle. We're working with triangles in quadrants. So we need to always use the full SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, and their reciprocals. No longer 1 are we using, because the hypotenuse is not 1 any longer. So here it says the sine of theta, which is opposite over hypotenuse, is 4/5. Opposite 4, hypotenuse 5. Then you should recall we have a 3, 4, 5 Pythagorean triple. If you don't remember that, then you need to work out Pythagorean theorem. A squared plus b squared equals c squared, and solve for this a, and you get 3. Again, any point quadrant 1 is a positive and a positive, so these are both positive, so there's our triangle. That takes care of the information that we need now. Now we go ahead and answer the trick question. What is tangent? TOA, and tangent is opposite over adjacent. So we just go to the opposite side over the adjacent side and we get 4/3. Down here for number 2, if we're doing that same thing, we have cosine of theta is 40 over 41. Cosine is adjacent over hypotenuse. So there's the 40 over 41. And 9, 40, 41 is a Pythagorean triple, or you use a squared plus b squared equals c squared. You're going to solve for the missing side and get your 9. Again, quadrant 1, positive, positive. Now we do tangent, just like it was number 1, opposite over adjacent, 9 over 40. Okay, now let's say we go down to here, number 3. It says in quadrant 4, so it tells me what quadrant it's in. So I draw my x and y axis, draw a triangle in quadrant 4, put my theta right here between the x-axis and terminal side, or between the hypotenuse and the terminal side. Terminal side and or hypotenuse and x-axis, also called terminal side and x-axis. Theta is always here. It's never between the terminal side and the y-axis ever. It's always right here. Okay. It's got to touch the x-axis. Okay. All right. So sine, opposite over hypotenuse, negative 15 over 17. Remember, hypotenuse must always be positive. So even if this negative was down here in the denominator, we'd have to move it up. Hypotenuse is always positive. Okay, and then we have an 8, 15, 17 Pythagorean triple. And we look at a point in quadrant 4. It's positive for the x, negative for the y. So I check, is my x coordinate positive? Yes. My y coordinate negative? Yes. So I have my triangle. Now I do the trig function it's asking for. Cotangent. Cotangent is adjacent over opposite. Adjacent again means next to, over the opposite across from. 8 over negative 15. Or you can move the negative up to the numerator and have negative 8/15. Okay. So there's a quadrant 4 one. Let's go down to a quadrant 3. Here we have quadrant 3. Okay, the others were quadrant 4 as well. So try another quadrant 1, quadrant 3 here. All right, so draw our XY coordinate plane, draw a right triangle in quadrant 3. Put our theta right here between the terminal side and the x-axis, or between the hypotenuse and the x-axis. And now it says the sine, which is opposite over hypotenuse, is negative 15 over 17. Opposite over hypotenuse. And then we have an 8, 15, 17 Pythagorean triple. I point here, any point that's plotted in quadrant 3 is both negative on both the x and the y. So I see my x has to have a negative, my y has to have a negative. They do, so they're good to go. Hypotenuse is always positive. So I have all my information. Now I go ahead and answer the question. Tangent, opposite over adjacent. Opposite negative 15 over adjacent negative 8. I cannot leave it as that because a negative over a negative is a positive. If you leave it like that, you're going to lose a point because you did not simplify the final answer. You can never have two signs in your final answer. You got to get down to one sign. It's either positive, the whole thing's either positive, or the whole thing's negative, not two signs. So 15/8 is my answer right there. Okay, so your questions, you're going to have 6 questions from this page and 14 questions between the inverse trig functions and actual sine, cosine, and tangent, just like this, just sine, cosine, and tangent. So between that and their reciprocals, you have 14 of these type, 6 of these type for a total of 20, and 1 extra credit question that I haven't gone over that you have to do some thinking about in regards to this side right here. Okay, and knowing your signs. Okay. And that covers it for the review. If you have any final questions on any of these that I didn't cover, you may ask during EL, come to EL and ask, or we can spend 10-15 minutes right before the test going over anything. And that concludes this video.